Hi there. In today's video, we'll be looking at the parameters of trigonometric functions, and the parameter we are focusing on is p. So we'll be looking at the effect of p, and p is this value here, which we either add or subtract to our x values, causing a horizontal shift. Horizontal shift. So this means that our graph is either going to move to the left or it's going to move to the right. So the best way for me to illustrate this is with an example. So we are going to use the graph of tan x. So y is equals to tan open bracket x, and the p value we're going to use is plus 45. I decided to use tan x for a change so that you'll be able to see how the asymptotes are also affected when we have these horizontal shifts. Okay, so let's look at the standard graph of tan x first before we incorporate the effect of p. And for us, p is positive 45. So here's our graph. I think I can shift it a bit more further up. There we go. So this is the standard graph for tan theta. We see that it starts at 0, and then when x is 45 degrees, we have y being equal to 1. And then from there, it keeps increasing and increasing until it hits that asymptote at x is equals to 90 degrees. Well, in this example, it was theta. And then continuing on, it starts increasing again. So it's coming from negative infinity over here. And then it increases. And when theta is 135 degrees, we find that y is negative 1. And then it increases to 0 at 180 degrees. And then it increases to positive 1 at 225 degrees. And then at 270 degrees, it hits another asymptote. And we see that it just keeps increasing to positive infinity. And then the cycle continues again until we reach 360 degrees. And what you can see is that for you to get a complete tan wave, it takes you about 90 degrees. Sorry, not 90. I'm looking at this 90 over there. It takes you 180 degrees for you to get a complete tan wave. So that complete shape there, it requires 180 degrees. And we can see that's between 270 and 90. So that's how we're able to determine that. And that cycle continues, and you have an asymptote every 180 degrees beyond 0 degrees and also beyond 360 degrees. Okay, so now we have a p-value, meaning we have a horizontal shift. And because p is positive, it means that our graph is moving towards the left. So let me write that. When p is positive, it means that graph shifts to the left. So it's going in this direction. So what this means is for all our x coordinates, we need to subtract 45 degrees. So we always take the opposite sign. Okay, so let us now sketch that. I think I'm going to have to duplicate this and then extend the x axis because that's what needs extension. The y axis remains the same. Then it's shifted down. I can move it more here because the graph is moving to the left. This should be fine. Okay, let's erase everything else. I think we'll just erase that. And let's extend our lines for x. So let's extend this to come all the way there. Okay, if that's 90, this should also be negative 90 degrees. And somewhere over there, we've got negative 180 degrees. Okay, so now let's incorporate our new graph into the same x and y axis. So P is positive 45, meaning the graph is shifting to the left. For every x value, we need to subtract 45. So let's start with the asymptotes. Let me add the asymptotes for the previous one before I start here. So this one continued like that. And then over here at 180, it looked like this. So this is the original tan graph. Now let's add the new one. We can make that one purple. Okay, so let's start with our asymptotes. So we're going to subtract 45. So if the original asymptote is at 270, when we subtract 45, you get 225. So here at 225, we're going to have one asymptote when we've shifted 45 degrees to the left. Next is 90. When we shift 45 degrees to the left, it would be 90 minus, so here we had 270 minus 45, which was 225. And here we're going to have 90 degrees minus 45, which is just 45 degrees. So that means that x is equal to 45 degrees. We've got our new asymptote there. And then the other asymptote was at negative 90. So minus 45, that is now at negative 135, which is somewhere in between here. So that has shifted 45 degrees to the left. So this is minus 90 degrees minus 45, which gave us negative 135. I'm only indicating the calculation for the asymptotes, the coordinates. I'm just going to show the new coordinates. Okay, so now that we've moved that graph 45 degrees to the left for our asymptotes, we need to do the same thing for our x coordinates. Okay, the tan graph is, yeah, it's not fun, but we can do this. Okay, starting at 360 degrees, when we subtract 45, it means that that point is now 315. So it's now here. So for the original tan graph, at 315, that's when our y was negative 1, so this point over here. When we shift that point 45 degrees to the left, that's 315 minus 45. That means it has now shifted over here. So now to join these, it looks like this. And we need to do that for all the points. So Next is the point that was at 225. That now at 225 we had y being positive 1, so that has now moved minus 45. It means it's now here at 80 degrees. And then the point that was at 80 has moved to 135, like here. And the point that was at 135 has moved to 90. So I think you guys have gotten the hang of the pattern. So let me join those. And then here it comes like that. And there we go. Okay, and then let's draw the last set. So let's start. We had a point at 45, so that moves 45 degrees to the left, meaning it's now here because the y values are the same. And then 0, 45 degrees to the left is now over here, and negative 45. And then we also had point at negative 45, which is now over here. There we go. So now I can join all my points. Like that. And then like that. Wow, we finally completed it. So this then is the new graph of tan x plus 45 degrees. And we have shifted 45 degrees to the left, because when p is positive, we take the opposite sign, meaning we are subtracting 45. Okay, so this is the effect of p. And the opposite is true when p is negative. So I can write that somewhere here. So when p is negative, there is a horizontal shift to the right. So you expect your graph to move to the right. For example, so I'm not going to sketch this one. This can be a challenge for you to try by yourself. If you have y is equals to cos open bracket x minus 60 degrees, what this means is that, can use a different color. What this means is that the graph of cos x will be moved 45 degree shift to the right. Okay, so give this last one that I'm not going to sketch a try and let me know how it goes in the comments down below. Don't worry, the graphs for sine and cos when it comes to horizontal shifts are much easier to sketch compared to the graph of tan. So that's why I rather showed you how to do the tan one. So I started with the difficult one so that you guys can try out the easier ones. Okay, that's it from me. Bye.